Hello everyone, my name is Dan. Welcome to my tutorial about quick UDP internet connection. Quick. So after this tutorial, you will gain an understanding of the definition of quick, why it is matter, and we also discuss about how quick improve the data delivery, its advantages and disadvantages. We also explore some real-world applications of quick, its security breadth and its scalability. And finally, we will analyze quick in action using Wireshark. So what is quick? Basically, QUIC is a transport layer protocol. It runs on top of UDP and developed by Google in 2012 and later standardized by IETF. The main goal of QUIC is to inherit the strengths of TCP and TLS, which are reliability and high secure connections. But it's unlike TCP and TLS, QUIC can even involve these services in a single layer, and then it runs over UDP to provide a fast connection. Alright, so the next question is why we need QUIC. So to answer this question, we're gonna look at the limitation of TCP TLS. That's are the long round trip and the header byte blocking, and then how QUIC can resolve this problem. So in TCP and TLS connection, when we want to establish the connection between silent and server, what we have to do first is perform the three-way handshake. Yes. And now, to establish the security, we have to spend at least one more round trip to establish the TLS. That's the hello and the server hello. Then silent can request the request and receive the response from server. And you see that to establish the connection and ensure the security, we need two round trip and then one more round trip to send the first byte. So it's got 3 round trip. However, in the QUIC, the process is much faster because it don't need the three-way handshake. So we just need to establish the TLS, hello, and then this connection is now established, so we can request to the server, and the server can respond to the silent now. So it's much faster. So it just needs one round trip to establish the connection. It's about the header byte blocking. So for example, in TCP, we have the packet 1, 2, and 3. And in TCP connection, there's only one stream. So this all of the packets will go with a single stream. In case if the packet 3, the packet 2 is missing, so it means that the packet 3 is can transfer until the packet 2 is retransmitted. However, in QUIC, it's different because in QUIC connection, it includes multiple streams. So it means that this packet can go through a different stream, like packets 1 go in the first one, the packet 2 go through a second stream, and the final stream for the packet 3. And in case if a packet 2 is missing, we just need to perform the retransmission on the second stream. And the first stream and the third stream, we don't need to retransmit the data. So it can reduce the delay in the data delivery. So in the next session, I will explain about the frame formats of QUIC. So QUIC have two main parts. The first one is the QUIC header, and the second one is the payloads. So inside the payload, there are different types of frames, and each frame has different jobs. So for example, we have the stream frame, which carries the actual application data, and the ACK frames is used to acknowledge the packets that have been received, and the ping frames helps to keep the connection alive. The next one is the cytoframe. It carries the TLS handshake message, and the final one is the path challenge and path response frames. They are used to support the connection migration and also used to validate the new network path. So it means that QUIC use different kinds of frames types to handle different tasks efficiently. So in this section, I will discuss about the advantages and disadvantages of QUIC. So there are several important advantages of QUIC. The first advantage is the fast connection establishment, because QUIC reduce the number of round trip, because it's like 1 or 0 round trip, so user can start sending data more quickly. The second advantage is multiplexing. QUIC can manage multiple streams within one connection, so it can improve the performance and reduce the delays caused by packet losing. The third advantage is the connection migration. This is very useful, especially for user mobile, because for example, if someone they change from Wi-Fi to mobile data network like 4G or 5G, the connection can continue transferring data without restarting like TCP. The final one is TLS by default, because the security is built-in. Encrypted communication is a standard feature. It's not an optional extra. However, QUIC also has some disadvantages. The first one is the implementation complexity, because QUIC includes the built-in TLS and many advanced features, so it can increase the risk of bugs or the implementation errors. The second one is QUIC may be blocked by some firewalls or middle boxes, because it's UDP, so some network may restrict or filter it. The third one is that QUIC is more difficult for monitoring and debugging, because it have the instruction by default. And finally, because QUIC has the built-in TOS, so it may require more CPU resources. So now let's look at some real applications of QUIC. So QUIC is already used by the large platforms such as YouTube, Facebook, and Instagram. For YouTube, QUIC helps reduce the latency and improve the video delivery. For in the Facebook and Instagram, where it can optimize the feed loading and the performance of media. Moreover, QUIC can also useful in the video streaming, because QUIC improves the buffering and adaptive bitrate streaming. And finally, QUIC is valuable for online gaming because of the lower latency and can reduce the lag and create a smoother in the multiplayer experience. So even though QUIC is secure, it still face some security threats. So the first one is the amplification attacks. Another is the denial of service, DOS, where attackers create too many connection attempts. And there also a risk of replay attacks in zero round trip, because early data can sometimes be relayed. And finally, there's might be some like the metadata exposure even when the content is disrupted. And to reduce these risks, we have some solution here is for the amplification attacks. Server can apply the anti-amplification limits and the rate limiting. And for the DOS, QUIC can use the stateless retry to validate the silence before creating the full connection. And next, for the replay attacks, what we can do is that we can limit the use of zero round trip or to apply the replay protection. Finally, to protect the metadata exposure, we need the stronger encryption methods. So finally, we talk about the scalability. So QUIC is considered as scalable protocols for several reasons. First one is it support the future extensions such as the multi-path QUIC and the loading balancing. Second, implementation of interruption can continue to optimize to reduce the computational costs. And third is the connection migration can be improved even further. And most importantly, QUIC is already designed for the cloud scale application, which is why the companies like Google, Facebook, and the Cloudflare use it. So in the next part, we will analyze QUIC using Wireshark. Alright, so to analyze the QUIC connection in Wireshark, I'm gonna use the filter to qualify some QUIC connection. So as you can see here, because QUIC is doesn't use the three-way handshake like TCP, it's don't need to perform the three-way handshake because it runs over the UDP. So first of all, the first thing that we have to do is establish the security using TLS 1.3. So that's why the first packet is the first packet that the silent sent to the server is the initial packet. It contains the cytoframe which carries the TLS handshake message, and then the server also responds to the silent by another initial packets. It also contains the cytoframe with the TLS handshake message, and it acknowledge the packet sent by silent. So it means that by now the TLS the security is now established. And after that, server and silent gonna exchange some handshake to make sure that the connection is established successfully. And after that, server and silent gonna send and request some packets. So here, let's look further into a buckets. So you can see the information here is that the payload is now protected. So it means that it is interrupted now, and we cannot see the content of the packet easily. So here, as you can see, we have the user data frame protocol information with the short port and the destination port number. So it's confirmed that QUIC is running over UDP. And in the QUIC information, we gonna have like the packet length 1197. It include the QUIC header and the QUIC payload. And each of the QUIC packets, it have the connection ID. It is now interrupted. So connection ID is used to support the connection migration. So it means that when a user they change the network, so it means that the short port number and the destination port number may change, but each packet is identified with the connection ID as well. So they also can maintain the connection without restarting because it have the connection ID. And also we can see here is the payload. So the payload here is now interrupted. So you can see you cannot see the content in the payload anymore. Yeah, so that was all of my tutorial today. So after this tutorial, you successfully gain the understanding of QUIC, what it is, the definition, why we need it, the pros and cons, and we also perform some analysis using Wireshark. And if you have any question, please comment below. I will answer it. Thank you for watching.